Good morning. And I am going to be having this recording for you to follow along with. The work that you're going to be doing today is graphing ratios. So some of the items will be looking for the relationship or filling in a missing table and then graphing the results. Remember when we did graphing earlier, we always graphed X first, Y second when you're looking at your coordinate points. This is going to be the same thing. We're going to be graphing X first, Y second, or your independent variable, which is the X, and your dependent variable, which is the Y. And for right now, if you're sitting in seat number 1, go get the math journals for your group quickly and quietly. Ready? Go. Okay, you should have the books passed out by now. And looking at the page number on this first slide, page 59. So open your journal to page 59. And let's go over the what, the why, and the how. What we are learning today, you will be looking for missing values from a table, comparing the rates, and graphing the equivalent rates. Why are we learning this? Being able to look for patterns with ratios and graph the results helps us to clearly see the math patterns. And how we will know we have learned this. 1, you're going to read the problem. 2, identify what is being asked. 3, complete the table or graph the points. And 4, find the equivalent ratio. So let's take a look at vocabulary that you're going to be using. And again, looking at the points. There is not going to be a problem of the day for today. I want to make sure that you have enough time to get through the graphing and setting up your graphs. So we'll not work on problem of the day, and we'll go back to that on Tuesday. So ratio, unit rate, equivalent. We've gone over all of that before. Ratio reasoning is the mathematical relationship between two quantities. When you're looking for that pattern, what did you do with the first number to get the second number? That's that mathematical relationship between the two quantities. And this is a good review of what we did with the coordinate plane. Remember, the x-axis is your horizontal axis. The y-axis is your vertical axis. Numbers to the left of 0 on the x-axis are your negative numbers, and numbers below the x-axis, when you're on your y-axis and you cross over the x and go below 0, those are your negative numbers for the y-axis. You're not going to be using any negative numbers for the work that you're going to be doing today. So your work is all going to be in quadrant 1, where your values are positive and positive. Okay, and then the ordered pair are the two numbers used to show the position on a coordinate plane, also called a coordinate pair. So let's get started with teacher input. Remember, teacher input model, you are looking up here. You are not writing in your book. You are not looking anyplace else. You're trying to make sense out of what we're going to be doing. So on the clearance table, 2 comic books cost $6. At that rate, how much would 7 comic books cost? How many comic books can be purchased with $27? Well, the first thing I'm going to do is find the unit rate. I know it's 2 comic books are going to cost $6. 2 goes into 6 3 times. So my unit rate is 1 comic book is going to cost $3. Once I know the unit rate, I can find the value for 7 comic books. Okay, 7 comic books are going to cost, well, if my unit rate is 3, 7 times 3 is 21. And how many books can be purchased with $27? Well, again, I know they're $3 a book. 3 goes into 27 9 times. So now I'm going to plot this information. And my unit rate is 1 book is $3. When I buy 2 books, that's $6. The next one I have is 7 books. Make sure I stay on the right line. $21. And when I buy 9 books, I'm paying $27. Now, I can take a look at these coordinate points, and I can draw a diagonal line through all of them. And all of these points will lie on that diagonal line. This is what's known as a linear equation. These points, they're not vertical or horizontal, they're diagonal, but they all increase. If I were to go to the 3 books, each one would go up by 3 points. Okay, so that is graphing your information once you determine the unit rate and you know what the additional costs would be. Looking at the second teacher input, you are going to have graphs, and it asks you to identify the unit ratio and write a statement that describes the data on the graph. Well, I'm going to take a look at, I have gallons. This is my independent variable. This is my dependent variable. Remember, we talked about the changes, where the independent are where you would make changes. Dependent is what you're measuring. So here are my changes. If I have 1 gallon, I'm going to pay $4. If I have 2 gallons, I've increased the gallons, and I'm going to have $8. If I have 3 gallons, I'm going to have $12. If I have 4 gallons, I'm going to have $16. And notice again that diagonal line for linear equations. So each time you increase, it's going up by a value of 4. Okay. Independent is your x-axis. Dependent is your y-axis. You're comparing gallons to quarts. So that would be your statement. I am comparing gallons to quarts, and the unit ratio is 1 to 4. You're comparing gallons to quarts. It's a 1 to 4 ratio. Okay, structured guided practice. So you're going to be following along with what you have in your book. I made my graph larger than what you see in your book. That was way too small to try and write numbers. I want you to number your x-axis in your book, and I want you to number your y-axis in your book so that you can then, after we work this out, plot your graph. So pause the video here, take 2 minutes you'll notice that your graph is, the cells in the graph are really, really small. So you might want to have the numbers go by, or have two cells to an area. So instead of just one cell, you may want to skip over to the second vertical line and put your number 1 there to fit this in. Okay, 2 minutes, set up your graph, pause the video here, and then we're going to come back in after you've got your X and Y axis numbered. Okay, so I'm looking at Tom and the number of stars he makes and the time it takes him. And I'm looking at Max, the number of stars and the number of times it takes him. And the question is, are they making them at different rates? Well, I'm going to use green for Tom's, and I'm going to use orange for Max. And I'm going to start plotting. When it takes him 2 hours, he is able to make 6 stars. So you're putting your first dot at X2, Y6. And then 4 and 12. And the last one I have here is 8 and 24. Okay, so you should have those plotted. And now I'm going to start plotting my information for Max. When he has 3 hours, it takes him, or he makes 9 stars. Notice this is my y-axis is going up by 2, so 9 is going to be in between. When he works 5 hours, he makes 15 stars. When he works 7 hours, he makes 21 stars. Well, if I look at the progression of the dots, it seems like they are going in a diagonal line. So to prove that, and sure enough, if I look at from 2 to 6, what did you do with the 2 to get a 6? And that went up by 3. So 2 times 3, 4 times 3, 8 times 3. And from 3 to 9, you're multiplying by 3. So the relationship is multiply by 3, and there is your linear equation for the growth that you're noticing. So pause the video here for 2 minutes. And I want you to make sure that your graph looks like this. Okay, let's go to the next structured guided practice. Identify the unit ratio and write a statement that describes the data on the graph. Just like we did for the teacher input, we're going to read the graph, and your statement is going to state what the ratio is and what you're comparing. So let's take a moment and look at the graph. We have fizzy water, cups of fizzy water, and we have cups of juice concentrate. So we're comparing fizzy water to juice concentrate. I also want you to label your X and your Y axis, and I want you to label this as independent variable and dependent variable. So now, pause the video here. I want you to talk with your partner, take a minute, and decide what is happening, how is the progression occurring, and what would the ratio be? What is the ratio of fizzy water cups to juice concentrate cups? Pause here for a minute and then check back in. Okay, so I'm sure in your discussion, you compared fizzy water to juice concentrate. And when you have 1 cup of fizzy water, you have 2 cups of juice concentrate. When you have 2 cups of fizzy water, you have 4 cups of juice concentrate. When you have 3 cups of fizzy water, you have 6 cups. So your increase is going up by 2. And your ratio for fizzy water to juice concentrate is 1 to 2. Make sure you have that statement written down. You're comparing fizzy water to juice concentrate, and your ratio is 1 to 2. So that you have that statement completely written, pause the video here for another minute. Make sure you have all the details recorded, and then we'll continue. Okay, moving on. Final check for understanding. Because you are watching this on the video, we're just going to work through all of these rather than having you work quietly and then having your work checked. So we're just going to work through them like structured guided practice. So the bakery sells 4 large cupcakes for $16. At this rate, what would be the price of 9 cupcakes? How many cupcakes could be purchased with $40? Well, I'm going to look at my ratio here. I have 4 and then 16. So what did I do with the 4 to get 16? And going to multiply by 4. So if that is my ratio, 9 times 4 would be 36. I know I'm still using a factor of 4, but I'm not going to multiply this time because I have the amount of money I need to determine the number of cupcakes. So I'm going to use inverse operation. Instead of multiplying by 4, I'm going to divide by 4. 4 goes into 40 10 times. And just to double check, 10 times 4 is 40. So now I have my table, and now I can start graphing my information. When I have 4 cupcakes, I pay $16. When I have 9 cupcakes, I pay $36. When I have 10 cupcakes, I pay $40. I'm going to, again, draw my line, and sure enough, there is another linear equation. So pause the video here for about a minute. Make sure you have all of these details and that you have, actually, because you have to set your graph up. So pause the video here for 3 minutes. Make sure you have your graph labeled, that you have your X and your Y axis, X and Y, and this is your independent variable, This is your dependent variable. Okay. And then plot your dots, or plot your coordinates, I should say, and be ready to move on at the end of 3 minutes. So pause here. Monitor to make sure all of the students are getting all of these details in their book, and then in 3 minutes' time, we'll continue. Okay, so you should have all of this information in your book. Now, identify the unit ratio and write a statement that describes the data on the graph. Well, first, I want you to add your X and your Y axis. I want you to add your independent variable and your dependent variable. And then my independent variable is the weight of turkey in pounds. My dependent variable is minutes that it takes to cook it. So I want you to talk with your partner, and I want you to determine what the ratio is by looking at the graph and reading the graph. Be careful, because this is going up by increments of 10. This is going up by increments of 1. So make sure when you're reading your graph, you're reading it correctly. You might want to double check by looking at all of the points to make sure that the interval of increase is the same. So take about 1 to 2 minutes, have that discussion, and be ready to state what you're comparing and what the ratio is. Ready? 2 minutes, go. Okay, so we're back. And when you have 1 pound of turkey, I'm reading this right here. This is 10, this is 20. This is halfway between 10 and 20. So I'm going to call this 15. But I also want to double check and make sure that the increments are correct. Well, if I have 2 pounds, if this is 15 and I'm multiplying that by 2, this should be 30, and it is. Then my next increment, if it's 30 plus another 15, would be 45. And that is what this is. Halfway between 40 and 50 is 45. And then this would be 60, and sure enough, it's 60. So now you can be sure that you've read your graph correctly. And remember, we're comparing weight of the turkey to the minutes cooked. And my ratio is 1 to 15. Okay, 1 pound of turkey, 15 minutes per pound to cook. So there's your unit ratio. And your statement should be written indicating that you are comparing the weight of the turkey to the minutes it takes to cook the turkey, and your ratio is 1 to 15. Now, tank tops are on sale at the rate of 3 for $15. How much would 7 tank tops cost? How many could be purchased for $60? And then graph the points. Notice I did not put a graph here on this one because you should be able to now take a look at the graph that you have and determine where you're going to write your interval points. But I am going to make the T chart here. So this is tank tops, and this is cost money. And 3 tank tops for $15. Figure out the cost for 7 tank tops and figure out if you had $60, how many tank tops could you purchase? So pause the video here for about a minute. You might first want to determine your unit rate. If you're looking at this and you're not quite sure what the value of 1 would be, okay, and 3 would go into 15 5 times. Okay, so pause the video here and determine what your amount would be for purchasing 7 tank tops and for how many you could purchase if you had $60. And come back in after a minute. Okay, so if we know that our factor is 5, 3 times 5 is 15, 7 times 5, you should have 35. And again, when I don't know the number of tank tops, but I know the money it's going to cost, I'm going to use inverse operation. We multiply to get the amount of money, but if I know the money, I'm going to divide to find how many tank tops. Well, 5 goes into 60 12 times. So I could purchase 12 tank tops. Now, on your graph, your x-axis, remember x is the horizontal, your x-axis needs to go out to 12. And your y-axis, your vertical is the y-axis, needs to go up to 60. So work together, set up your graph, and then plot the coordinate points that you have for your tank tops and the cost. Take about 3 minutes so you can number your graph, set up your X and Y axis, and then plot the coordinate points. Pause the video here and check back in 3 minutes. Ready? Go. Okay, moving on to the next item in student practice. Again, I have another graph, and I'm comparing laps completed to minutes elapsed or time it took you to run. Again, label, this is X, this is Y, this is independent variable, this is dependent variable. And then when you're reading, you're looking at your X and your Y and what those coordinate points would be. So pause the video here, take a minute, determine the ratio and what is the rate of increase. Pause here, check back in a minute. Okay, so again, we're comparing laps completed to minutes elapsed. And when I have completed 1 lap, it took me 5 minutes. Well, that means my next increase should be up by 5. So when I go 2 laps, if I am increasing by 5, 10 should be my next interval. And sure enough, it is. And then 15 and then 20. So I know that my ratio of laps to minutes is a 1 to 5 ratio. 1 lap, 5 minutes. 2 laps, 10 minutes. 3 laps, 15 minutes. 4 laps, 20 minutes. Make sure you have your statement and your ratio clearly written. And our next item is another graph to interpret. This time we're comparing flour to cakes made. And again, I'm looking at my x-axis Make sure you label X and Y. And independent variable, dependent variable. And when I have 1 pound of flour, and I'm looking at my intervals for my y-axis, and 0 and then 2. So 1 is going to be halfway between 0 and 2. 3 is going to be halfway between 2 and 4. So I know if this is increasing by 2, the distance halfway would be the number in between the 4 and the 6, or in between the 2 and the 4. So when I have 1 pound of flour, this is halfway in between 2 and 4. So that means this is 3. So that means my next XY coordinate should be indicating that my cakes should be 6. So when I have 2 pounds of flour, sure enough, I have 6 pounds of cake. When I have 3 pounds of flour, well, if it's increasing by 3, this should be 9. And sure enough, halfway between 8 and 10, this is going to be 9. And when I have 4 cups of flour, 4 times 3 is 12. So when you write your statement, you're going to indicate you're comparing flours to cake mixes, and you have a ratio of 1 to 3. So pause the video here. Make sure you have indicated your X and Y axis. Again, discuss this with your partner and write your statement. Pause for 1 minute and go. Okay, here we have another graph. So you're getting lots of practice in reading graphs, which is good because you will see a lot of this on the Smarter Balance test. Again, XY coordinate. And remember the work that we did with independent and dependent variables. Now you're getting to see it. When you graph, your x-axis is your independent variable. Your y-axis is your dependent variable. As gallons of gas increase, the amount of miles driven are going to have a different measure. So this is what you're changing. This is what you're measuring. So pause the video here. Take a minute to discuss this with your partner. Take a look at how it is increasing and write your statement for your ratio. Okay? Pause here and go. Okay, coming back. When I have 1 gallon of gas, I can go 10 miles. So I should see increments of 10. So when I have 2 gallons of gas, it should be 20. And sure enough, it is. 3 gallons of gas and 30. 4 gallons of gas and 40. So your ratio of gas to miles driven is 1 to 10. For every gallon of gas, you can drive 10 miles. Okay, wow, we don't have a graph to interpret anymore. You have another word problem, and it gives us a rate of 2 necklaces that she's selling for $18. So start off on this one by drawing your T-chart. I didn't make my nice, neat lines, but that's okay. This is necklaces, and this is money. So set up your T-chart. 2 necklaces, $18. That's a dollar sign.